I'm going to take a quick look at this Hitachi 32LD6600B. 32-inch LCD. It's a Vestel set. I've serviced one of these before and it was failed caps on the power supply. However, today the symptoms are different. There's no backlight, so it's probably an inverter failure. And this has a 17MB15E, and I think the power supply is a 17PW 15-8. So, and it was from Cash Converters. Tested. Wow. Can't read the date. It's not very clear. So I'm going to take the back off and we'll see what's going on inside this TV. Okay, so here's inside of this chassis. This is a 17MB15E, as I suspected. And the power supply is a 17PW15-8. First thing I noticed, bulger there on the 5V, and a bulger there on the 12V. They're caps on caps, which, no surprise, caps on are some of the worst capacitors out there. So those are going to need to be changed. So here's the inverter. It looks like a Vestel inverter to me. I think it's got a crappy little cover on it, but panels are Chime-A, and with one of those massive T-cons, and I've actually repaired one of those T-cons in the past. Basically, there was a line out on the screen, and the rest of the screen was blank, and it was a failed voltage reg on the T-con. So we're going to diagnose this here. So I've got my multimeter. So we're going to see what's causing this no backlight failure. So turn the TV on. Oh, that's a problem. Going to need to hook up the power buttons because they're on this little PCB on this particular one. So just plug that in. Okay. Alright. The power supply is on, so let's turn on the... So if the power supply is at fault, we won't have any 24 volts. But as you see, 24 volts is present. It's at 23 volts. But, yeah, it's close enough. So now I'm going to check the backlight on signal, which I believe is the blue and orange. Yep, they're all working. So that means the failure is the inverter. So something on this inverter has failed. Now, we don't even get a flash of the backlight. Which basically is the backlight fires on then shuts down. We don't even get that, so it possibly means that the transformers and actual CFL bulbs are okay, but something in the driver section, so the MOSFETs and that on the inverter, has failed. So I'm going to take this inverter out. You have to peel off this glue, then I can unscrew it and inspect this inverter. Right, so I'm just going to check out this inverter. Check that the voltages are there. I'm going to check that 24 volts is coming in. And it is. On the second one, yep. Oh. So now I'm going to check the backlight on voltage. That's fine. The dimming voltage, that's fine as well. So there's some fuses. There's two fuses here, which are for the MOSFETs. And if one of these shorts, it'll blow the fuse, and none of the backlight will turn on. So let's check the output. That fuse is actually good, and that fuse is good. So I'm going to see if the MOSFETs are good. They should have 20. Yeah. So the top row of MOSFETs appears to be working. And the bottom row does as well. Let's check the adjust pin, I think. Ah! These MOSFETs aren't being driven then. Let's just check that again. Yeah, so these MOSFETs, the 24 volts is going through them, but they're not being told to go high. Basically when they go high, it runs the transformer. So something is actually up on the driver circuit. If I backlight, yeah. Yeah, there's a fuse here, I think, that's connected to the backlight on input. So 24 volts, and that fuse is actually blown. So I think the TV just went into standby. Yep. So let's just power that back on. There we go. Right, maybe it went off. Yeah, that fuse is blown. So this is the driver section, I think, for the MOSFETs, which basically tells them to go high and run the backlight. Yeah, there's literally nothing over on this section. It's dead. So something over in the driver section is actually shorted. Yeah, most of it over is dead. Without that fuse, I think that it's not going to work. And I have seen little pico fuses like this just fail at random. You know, they haven't needed anything to actually fail in the circuit to cause them to blow. But I'm going to have a look up and see if there's anything like known issues with this inverter, because it's quite strange. Well, not strange, but quite odd. The fuse for the driver section's failed, but yeah, little ceramic fuses like that I have seen blow, especially on T-cons and stuff. I'm gonna get. Hang on, is this a VIT? Yeah, it's a VIT 7002.60 inverter. I've repaired quite a few of these VITs. Not very good inverters. Anyway, I'm going to have a look up on Google and see what I can find. I couldn't find anything obviously wrong with this inverter or anything shorted. However, I was able to find a replacement on eBay for £6.90. So, and a fuse for this as well is 60p for a pack of 5 or something. Plus some postage as well. So, as I couldn't find anything shorted, that's all. I'm going to attempt, and this is something you should never do, I'm just going to bridge over that fuse and see if that is the fault. Of course, this is never a good idea to do, but as this is such a low current, low voltage section of the inverter, bridging over the fuse probably won't do much damage to the TV anyway. But bridging over fuses like this that are powering some high current devices could end up in a bang. So yeah, such a low voltage fuse and low current. I'm just going to bridge it over with some solder. There's nothing shorted obviously in this section, and I would need an oscilloscope to be able to diagnose anything, so let's just see what I can do. Alright, so I've bridged over that fuse, as you can see. Pretty neat. So, got the inverter hooked up. Let's just see what happens. If this smoke, I'll got my finger on the power button ready. It's up! Wow, that is a buzzy inverter. That was just a little blown fuse. That's pretty awesome. Now I'm going to show you the voltage on those MOSFETs, because now they are being driven. Or some. So, here's the drive pin, that's 17 volts now. MOSFETs are at 12 volts, however, there'll be a lot of current going through those. So, It's just a flaming simple blown fuse. And it's cost me nothing. Now there is one problem with this type of repair. Was something in that circuit breaking down and causing too much current to pass through it, which is why the fuse tripped? I don't know. And I'm not really able to test the current because I don't have an oscilloscope. I did resolder that transistor because the solder joint on that looked pretty crap, but I'm going to check my other inverters and see if I've got a fuse that will fit in place. Just in case if something does go wrong, it doesn't end up with loads of smoke, it'll just trip the fuse and that'll be the end of that. So yeah, I thought that something was getting hot there, but it was just my hand. So simple blown fuse. Let me check and see if I've got anything. And I'm also going to need to flame and recap this as well. Oh, Vestel. I'll get back to you. So I thought before I bothered to find a fuse, I'd just check the LCD. And there's no lines or anything out, so that's good. So, I found an inverter that has a fuse that I can use. It's a bit more current, I think about 200 milliamps or something more, but that should work fine. And then I'm going to find caps for this PSU. I'm replacing all the caps that have a blue marker on the top. So all the caps on and the G-Lux-ons. I'm not replacing the smaller ones because they seem to always be fine. But these bigger ones, these are prone to failure basically. And the ones that have failed are actually pretty warm, which shows there's a lot of resistance across them. When caps fail, the equivalent series resistance goes up, so the resistance goes up, which is why they're actually getting warmer than the other caps. So the ones that I'm replacing, there's 4 1000 microfarads, 2 1000 microfarad 35 volts, 2 4700 microfarad 6.3, a 2200 microfarad 6.3, 300 microfarad 50 volts, and a 47 microfarad 50 volt as well. These two provide the VCC for the PFC, so you want to make sure that those are in good condition. So, I'm going to test this, recap it, get a fuse on that. Hopefully should be case closed. Here's a look at the power supply. I had to put some bigger caps in place because I don't have any in that diameter. So that's all recapped. Got my initial, done the inverter, got my initial hidden under there. So let's reassemble this thing and see what it does. It's a good job I decided to film this because when I was assembling it I accidentally ripped this wire out of somewhere. There was one that was glued in, there was glue on it, but I've taken that off. Checking through the video, it goes to those two Zener diodes on the audio amp, so gonna have to resolder that and hopefully we will have sound. Oh, love Vestel's bodge jobs. In fact, this audio IC looks like it was hand soldered. Everything's sort of just glued together and just sort of bodged together. Vestel. They haven't changed either, so I'm going to resolder that wire and hopefully we get audio on this. Okay, so here's the TV now. There we go. Factory reset as well. I don't think it has Freeview, but I'm going to just try it anyway. And the failure was just a little fuse, so, and a few bad caps, but that wasn't causing any issues at the minute, so. Anyway, thanks for watching. It's been a repair of this Hitachi. with the VIT, I think 7002.60 or something inverter. So yeah, thanks for watching and see you in the next one.